Hi friends, welcome to Untitled. This is our first video in English. In this channel, we are discussing about various topics in engineering, especially topics from mechanical engineering. We have chosen the subject engineering mechanics for our first video. Today we are going to have a discussion on the topic introduction to engineering mechanics and force system. Okay, we can start now. First of all, we need to know about this subject engineering mechanics. It is defined as the following. That is, engineering mechanics is the branch of engineering science which deals with the application of mechanics to solve problems involving common engineering elements. For a mechanical engineering student, the common engineering elements are wheels, rollers, nut and bolt, springs, etc. So, the engineering mechanics help us to solve problems of these elements by the application of mechanics. Then what is mechanics? Mechanics is simply the area of mathematics and physics concerned with the relationship between force, matter and motion among physical objects. Then, why we need to study these engineering mechanics topics? It is because the primary purpose of the study of engineering mechanics is to develop the capability to predict the effect of force and motion while carrying out the creative design function of engineering. Our engineering mechanics topics help us to do designing by developing our capability to predict the effect of force and motion. Then we need to think about the classifications of our main branch, engineering mechanics. Engineering mechanics is divided into two classifications. First one is statics, the second one is dynamics. The dynamics section is further divided into two classifications. That is, first part is kinematics and the other second part is kinetics. Now we can think about each of the branches of this engineering mechanics. The first classification of engineering mechanics is statics, and statics deals with forces in terms of their distribution and effect on a body at absolute or relative rest. That means in statics the object is at rest condition and all our calculation and force distribution are done when the body is at rest condition. Then what about dynamics? Dynamics deals with the study of bodies in motion. We see that in statics we do force analysis when the object is at rest condition, but in dynamics we do force analysis and its effect on a body when the body is at moving condition. And the dynamics section is divided into two. First part is kinematics. The kinematics is concerned with the properties of motion only, such as velocity, displacement and acceleration. That means kinematics is focused on a body's motion parameters only, like displacement, velocity, acceleration of a body. And the second part is kinetics. The definition of kinetics is it is the study of explanation of motion. Also kinetics focus on the cause of motion dealing with the why. That means the kinetics focused on the reason behind the motion, such as force, power, torque, work, etc. The sub-branches of dynamics are kinematics and kinetics, and kinematics focused on the motion properties and kinetics focused on the reason behind motion. In case of our statics and dynamics, we are focusing on the force distribution and its effects on a body. Then what is force? Force is simply the action that tends to maintain or alter the motion of a body or to destroy it. That means in engineering mechanics, the force is a physical quantity that controls the motion of an object. We already studied about physical quantities during our 11th physics. So the physical quantities can be classified into two. First classification is scalar quantity. Such quantities only need a magnitude value to specify it. But there is a second classification, that is a vector quantity. Such quantities require magnitude and direction to specify that quantity. Our force is a vector quantity, so we need a magnitude value as well as a direction to specify a force. And the direction of force is represented by a force vector. That direction is represented by the line of action of force. The definition of line of action of force is as following. It is a geometric representation of how the force is applied. That means a line of action of force is simply the path of our force vector. Then we can go to our next term. It is force system. And a force system is a collection of forces acting at specified location. Simply, the force system is a term used to describe a group of forces acting at a specified location. Our force system is also classified into two. The first classification is coplanar force system and second classification is non-coplanar force system. In coplanar force system, all the forces are acting on same plane, and in non-coplanar force system, all the forces act on different plane. We can discuss more about this coplanar and non-coplanar force system on further videos. Now we can briefly think about the topics discussed in this video. Today we discussed about engineering mechanics. Engineering mechanics is divided into two, and the first part is statics. In statics, we do our calculations and force distribution system when the body is at rest condition. And the second classification is dynamics. In dynamics, we do all the force calculations and other force distributions and its effects when the body is at moving condition. The dynamics is divided into two subcategories. First subcategory is the kinematics. In kinematics, we focused on the properties of motion only. That means an object's or body's acceleration, velocity and displacement only. And the second classification is the kinetics. In kinetics, we focused on the reason behind the motion, such as force, torque, power, work, etc. And then we discussed about the force, line of action of force, and about force system. The force system is divided into two. First part is the coplanar force system, and second classification is non-coplanar force system. We can think about the non-coplanar force system more deeply in next video.